Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous two classes, we have been discussing about the chemical bonding, and I hopefully think that this is the last class on the chemical bonding. Okay, so specifically, we are going to today discuss about the formation of hydroxyl ion. In the previous class, we have seen how coordinate bond helps in the formation of hydronium ion. Similarly, we can see how hydroxyl ion is formed. Okay. So with that, we begin our class. So make heading formation of hydroxyl ion. Okay. So how hydroxyl ion is being formed? See, you have understood how the hydronium ion is formed. If not, you have watched the previous video. Please do watch the previous video. You will get the little concept about the formation of hydronium ion. Now, you can see the structure of water. I am redrawing it once again. So structure of water is something like this. Here is one hydrogen atom, oxygen atom in the middle, and there are two hydrogen atoms. Okay. So what happens? The hydrogen atom and oxygen atom, they individually share one pair of electron. Okay, this also hydrogen atom and oxygen atom share one pair of electron. Okay, and the oxygen has remaining two lone pair of electrons, that is 4 electrons revolving in its outer shell. Okay, so the 4 electrons, why they are called lone pair? Because they do not participate in the bond. Okay, coordinate covalent bond. Fine. Now, if this hydrogen, if the one of the hydrogen atoms out of the two leaves this bond, say this hydrogen atom leaves the bond formation without taking any electron with it, that is, it is giving away both of its electron to the oxygen atom, then what happens? Then overall there will be one electron more in the whole structure. There will be one electron more in the whole structure. Please just wait a 1 second. Okay. Just pausing the video a little bit. There's some technical disturbance. Okay, I think now the video is clear. Yeah. So the video is clear. Fine. Now see, when this hydrogen atom just leaves this bond, this structure, without taking away any electron with it, what happens? Basically, there will be one electron more in the structure, and as a result, the structure will be left with a positive charge, negative charge. Okay, excess of electrons, so negative charge. So something like this will happen. The hydrogen and oxygen atoms, they are still present in the structure. Okay, and they will be sharing their electrons as they were sharing previously. Okay, however, this oxygen atom has now one more electron in it than the number of protons altogether in the structure. So with this, what happens? Hydroxyl ion forms. This H plus ion gets separated. Why this H plus ion? Because it has taken no electron with itself. So this unique structure has a negative charge on itself, and this negatively structured charge structure, the negative charge is regarded as the hydroxyl ion. So this entire structure, okay, this entire structure will be something like this. It will be written as OH1 minus. So this is the hydroxyl ion that you have come to know. So what happens? Water has a self-ionizing property. Okay. So I am mentioning the term once again. Water has self-ionizing property. Okay. What does this self-ionizing property indicate? Water has a tendency to just break off into ions like this. So water often, what happens, just dissociates into OH minus ion and H plus ion. So if you just write this in the equation format H2O. This is a reversible process, so we just denote a reversible sign here. H plus and OH minus ion are being formed. As a result of this, what happens? Not all the atoms in the water, in a certain volume of water, ionize like this. Okay, there are certain molecules which may not be ionized. Okay, so what happens then when those atoms do not get ionized? What happens? This H plus ion that is being formed, they go on to attach themselves with those water molecules. And as we have seen in the previous class, that when H plus ion gets attached with the water molecule through a coordinate bond, okay, through a coordinate bond, it results in the formation of a hydronium ion. Okay, so this self-ionizing property helps in the formation of hydronium ion. How? So I think you have noted how this hydroxyl ion is formed. I am just repeating it once again how the hydronium ion is formed. I have shown this in the previous video, but just for your clarity, this H2O molecule will get attached to the H plus ion. This is actually a coordinate bond. Okay, this is actually a coordinate bond. This coordinate bond results in the formation of H3O plus ion. Okay, so this results in the formation of H3O plus ion. Again, fine. So this is how hydronium ion is being formed in water. Okay, so I think the concept is clear. Now let us move on to the next topic, last topic for this chapter, where we will be discussing one chemical compound which has all three kinds of bond, that is electrovalent bond, covalent bond and coordinate bond. Okay, can you guess such one compound? The name of that compound is ammonium chloride. Okay, ammonium chloride. This ammonium chloride has all the three bonds present in it. Okay, how? See, now you know that the structure of ammonia is a basically covalent bond. We'll be just showing the formation of ammonia molecule. So here is one hydrogen atom, here is one hydrogen atom, and here is one hydrogen atom. Okay, as I have discussed this already in the previous class. Okay, so hydrogen atom shares one electron like this, and nitrogen atom also shares one electron with each of the hydrogen atom, and there is a lone pair of electron. Okay, now this ammonia molecule, what happens, gives away this lone pair of electron to a hydrogen ion, H plus ion, hydrogen ion or H plus ion. When this lone pair of electrons given to the hydrogen ion, what happens? It results in the formation of a ammonium ion, NH4 1 plus. Yeah, correct. I think you remember this. And this ion, when a chlorine ion comes nearby it, Cl1 minus, due to the attractive force between the chlorine ion and the ammonium ion, what happens? Electrostatic force of attraction between the opposite charged ions, they come together and lead to the formation of ammonium chloride, molecule of ammonium chloride. So this is a compound. Okay, so this compound consists of basically all three kinds of bond. So I hope the concept is clear. Okay, with that we basically come to the end of this class. Also we come to the end of this chapter. In the next video we will be starting some new chapter again. Till then, please do study well. If you have any query, mention it in the comment box. We will be happy to solve your problem. Thank you. Goodbye.